One good day, pre-algebra. We're covering PO16. We've progressed through our unit. We started with expressions. We wrote expressions. Then we graphed expressions. Then we plugged values into expressions. Now we're coming to equations, where yesterday we plugged something into an equation to see if it worked. Now we are going to actually solve an equation for a variable. I just heard the comment, someone say, this is easy. That's great. I would be shocked if you've not done something like this before, okay? But what we're doing here is we're building up to, right, equations that are going to be more challenging than n plus 6 equals 18. I say this every single year, and every single year some people ignore me, and every single year some people come to me at the end of the year and they say, I wish that I would have listened to you back in November 8th, because every year I say this on November 9th, okay? And I wish I would have listened to your warning. Here's my warning. If you can do this mentally, that's expected. That's awesome, okay? I'm requiring you to show your work and show me the process, because eventually, in the not too distant future, there will be equations you can't do mentally because they're too long, you have multiple variables, you have multiple steps, they're just going to get too complicated. And if you don't know the process to solve an equation and you can't do it mentally, what are you going to do? What's every middle schooler's favorite method?
Google.
Well, on a test, you can't use the Google. Can't use photo math on a test either. That would be mentally, but we're saying you can't do this mentally because there will be equations. You're going to guess and check, right? And guess and check, even though it's a viable method, I use guess and check from time to time. It's not very efficient, okay? It's a slow method. You might get lucky and guess correctly in the first couple times, right? But if your answer's like, 5/7, how long will it take you to get 5/7? Probably a while, okay? So it's not a very efficient method, okay? And you're going to get frustrated. And you're going to come to me and say, I don't know how to do this. I'm going to say, use opposite operations. You're going to say, I don't know what those are. And then we're going to be back at square one anyway. So if you can do it mentally, awesome. Good for you. I'm proud. Great job. Yes. But learn the process. I'm going to require you to show the work, and I want you to do it the way that I'm teaching you for now. Blake. We'll get there. Okay, so Lizzie, even though there's so much more to algebra than solving for a variable, it's what most people think about algebra is all about. Okay, people think algebra, they think of variables, solving equations. Cade, Abby, here we go. Okay, we are going to cover 3 ways to solve the same equation, none of which are necessarily mental. Okay, so that when you see an equation, these are the 3 ways you can think about it, and you can make your best decision from there. Logically, the expression as a question. How could you kind of identify this equation? I shouldn't say expression, I should say equation here. How could you identify this equation and ask it as a question? Cade. Sure. This goes back to when we started writing equations at the beginning of the unit, CO13 or 14, something like that. What number plus 6 is 18? Right? That's essentially what this is asking. Okay? And from there, you can kind of answer it mentally, probably. What number plus 6 is 18? 12. Okay? And so n would equal 12. Okay? The second one, opposite operations, this is the one that I want you to use for now, because this is a method that will work for every equation that you will come across. No matter how long that equation is, no matter how many steps the equation has, no matter how many different operations the equation has, opposite operations will always work. Yes?
Could you also do 18 minus 6 equals what number?
That's essentially what we're going to do now. Yes. Okay. In last year's math class with Mrs. Feynman, did you talk about railroad tracks?
Yes.
What are railroad tracks, Annie? Hey, Jeffrey, Jack, warnings for each of you.
It's like this thing that you put down when you're doing like portions or something.
Proportions?
What?
You can use it with proportions. Tony, warning for you.
That's all I remember.
Okay.
Like she'd always say proportions.
So when we get to proportions, I'll come back to you for that one. But in the context of equations, who remembers what the railroad tracks were? Yeah.
It's basically where you're subtracting on both sides of it.
Yeah, and you kind of drew your tracks down along the equal sign here to kind of separate the two sides, right? If you want to draw railroad tracks, that is perfectly fine. If it kind of helps you remember what to do. I'm not nearly as creative as Mrs. Feynman is, so I just call this opposite operations. But what Kate said, where you subtract 6 from both sides, that's exactly what opposite operations is. Okay? Now, let's dissect this a little bit. Why do we subtract 6 from both sides? Why do we subtract 6, Abby? Okay, Cade?
Because you were adding first.
Because it's the opposite operation of adding 6, right? In the equation, it says n plus 6. If our goal is to get the variable by itself, we want to undo everything that's being done to the variable. So since we're adding 6 to the variable, we are going to use the opposite operation and subtract 6. So are we going back to PERMDAS here? Yes, we are, right? PERMDAS, addition, subtraction, we said they're opposites, okay? If we see adding 6, we are going to subtract 6. What does that do for us on the left side here? What happens when we subtract 6 from n plus 6? Yeah.
You cross it out.
6 minus 6 equals 0, right? So what's left on the left side? Just n, right? If we take 6 away from n plus 6, we're left with n by itself. Why do we also have to subtract 6 from the other side? Jeffrey?
You have to do what you're doing the same to both sides.
Right, the golden rule of math, right? Treat unto one side as you treat the other, or something like that.
Sounds like a commandment.
That's what's kind of the joke, yeah. Okay, but yeah, we have what we do to one side, we have to do to the other side, because that equal sign, it means things are equal. It means things are balanced. This is my best drawing at a balanced scale that maybe you've used in science class before. Okay. If on one side you've got n plus 6, and on the other side you've got 18, and that equal sign is kind of like that center post. It says the two sides are the same. Those two sides are balanced. If you subtract 6 from one side and not the other, you take 6 away from one side and do nothing to the other side, what's going to happen to your scale? Right? It's not going to be balanced anymore. Okay? So in order to keep these two sides equal or the same, you have to do it to the other side as well. And we get 18 minus 6 equals 12, n equals 12. That was a very verby, wordy explanation for a relatively simple idea that you've all done before. But it's important to understand why we do what we do. Okay? We don't just subtract 6 from both sides because I said to. Okay? There's a reason behind it. We want to get the variable by itself, and we have to keep both sides the same. Dayton. Yes. Okay. Any questions on this? All right. I'm not going to show you fact families because A, due to time constraints, and B, it's just a little bit something extra that I don't want to clutter your mind with. So what I want you to do is, it says using 2 methods from above each time. I only want to see one, and I want to see opposite operations. Okay? And when I say I want to see opposite operations, this is what I want to see. So if you lost points on today's homework for not showing work, pay attention right now, because this is what needs to be on your page tomorrow. Okay? You need to show me what you're doing to both sides of the equation to get the variable by itself. What would you do in this first one here to get n by itself? If you want to put the train up, that's perfectly fine. Okay? But what I need to see, Griffin, which in this case would be what? What would you do here to get n by itself?
Train tracks and you
Subtract 8. The reason why we subtract 8 is because 8 is positive. The plus sign isn't written, but it's a positive 8. And the opposite of a positive 8 is a negative 8. If you want to draw the train tracks in, great. They're not required. Okay? They're optional. If they help you, use them. Right? So 8 minus 8 gives us 0. N is by itself. And 25 minus 8 is 17. Jack?
Could I say 25 minus 8 equals n, and then n equals 17?
I want to see this process. I want to see the opposite operations process.
But then I have the 25 minus 8 written here.
I want to see this process. And again, I'm asking you to trust me, Jack. There will come a time when you will not be able to write an equation verbally and have it make any sense. Because our equations are going to get longer with more operations. Okay? So I need to see this process. You understand the opposite operations process. Right?
Yeah.
Jeffrey?
Can I do all three for fun?
Yes. Math for funsies sounds like a great idea to me. Wyatt?
Wait, so for the second one, do you do 13 plus 13?
It'd be negative 13 plus 13, but yes. Yes. Remember, this sign belongs to the 13. That's a negative. We read it as n minus 13, but it's also a negative 13. So yes, you would add 13 to both sides because what's negative 13 plus 13? 0, right? And then you get n equals 32, okay? The other part of this that I need to see, Jeffrey, you want to listen to this? The other part of this that I need to see, we would not have done PO15 if it weren't for a reason. So once you get your value for n, you then have to go back and check it. Just like CO15, you're going to put 17 back into the equation and verify it works. Right? CO15, the whole point of it was plugging in a variable to see if the equation works. You must do that here with your answer. So you solve it, you check it. You need to show me you've done both. Okay? The next one, we got n equals 32. That's our answer. So we're going to go back to the original equation. We're going to plug 32 in for the variable, and we're going to see if it works. Does 32 minus 13 equal 19? Yes, it does. We know that we're right. Okay, Jack?
We have to do the last page.
Yes.
What?
It's not that. I don't even know.
The second page is homework for tomorrow.
All of it?
All of it.
I'm doing it right now.
I need to see the work. I need to see that you've checked. Okay? You take what you get, you go back to the original equation, you plug the value in for n and see if it works. The exact same thing you did for CO15, right? You can still do the train. What's your train for checking?
I'm almost on the backside of it.
But when you say do the train, what do you mean by do the train?
I just put up like right.
You can put the railroad tracks on there, yeah. But I still need to see that you've checked it.
I'll let you know.
You take the value that you get for n, like we got n equals 32 here. I've got Kirby train tracks, okay? Right? Then I take that value for n, I go back to the original equation, I plug it in. Instead of n, I put the value that I got and see if the equation works. Okay? Abby?
So for the first one, since it's addition, could you say 17 plus 8 equals 25, or do you want the exact expression?
It's always best to put it back exactly as it was, because sometimes you might miss a sign or something. So if you did put 17 plus 8, it wouldn't be wrong in this case, but it's best to go back to the original expression. Haley? Yes, the word problems as well. Those are more open-ended. I don't need to see. Well, I should say that. Yes, do the word problems, show your work. Yes. Okay. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Thanks, John. Jack?
Complaints, like, I had to erase my whole paper.
Well, remember earlier when I said some of you like to jump on the homework, but it's a good idea to wait to hear directions first? That would be why. Cade? This is a sponsored video today, stickermule.com. If you order a certain number, they also send you a bottle of hot sauce, which I thought was weird at first, but it was delish. Delish. Stickermule.com. Sponsored video today. Actually not, but Jeffrey. A dance? I already have a song in the works. I gotta go. It's 9:15. Have a nice day, folks. That's how you math.